So the first one, we are supposed to do a lot of things. A f of x equals e to the x minus 2 plus 1. All right. So let's start with the domain. So the domain is all real numbers because it keeps on going to the left forever, it keeps on going to the right forever. It just goes slower to the right, right? What about the range? Is it what?
1 to infinity.
Or is that what you were going to say or something else? Yes.
1 is not inclusive?
1 is not included. That's where the asymptote is. True enough.
Okay.
Okay. The intercepts. So what is the process for finding the x-intercept?
You set the x to 0?
Other way around. We do it, yeah. So we do the opposite one to find the one we're looking for. So 0 is e to the x minus 2 plus 1. So how do we solve this guy?
Do you set both sides to natural log? Yeah.
So not yet. That is a method that we can use, but we have to have, well, we want this to be by itself. And I would actually argue there's an even easier way to solve this one, which we'll do here in a second. So, and actually we could, well, the more experience you get with this kind of stuff, the more you could probably just like stop right here and be done with this one. But so we could take the log of both sides. That is a thing that we could do. Or we could just convert this to logarithmic form, right? What would this be in logarithmic form?
X minus 2
Oops, what am I doing?
to the negative, no, x minus 2.
Equals log base e, so natural log, of negative 1. Just for you, because we're not intuition quite there yet, punch the natural log of negative 1 in your calculator and see what happens. Hola, ¿cómo estás? You should go take your test. That's correct, you can't. Merry Christmas.
I know?
Yes, sir.
Okay. Should I take it in the other room?
There's like hardly anybody here, so if you want to go in here, I think Josiah's in here, you can do it in there, or you could do it in the back. I don't think there's anybody back there today, so your preference. Whatever works for you, sir. Good luck. Holler if you have any questions.
So there's no...
So, does not exist, yeah? D&E. There's no, your calculator what? Uh-oh, gotta charge it. Okay, so that's x-intercept, doesn't exist, done and dusted. The y-intercept. What is the process for finding the y-intercept?
Set x.
0x.
Yes. So we're finding f of 0 in this case. All right, so we want e to the negative 2 plus 1, which is going to be approximately equal to something ugly, right? 1 point something. How's it going, Garrett? Good. 1.35 is probably plenty good enough, yeah? Y-intercepts, great. That. Next thing, it has a horizontal asymptote, right?
What? Oh, wait. No, just kidding.
Where is its horizontal asymptote? At y equals 1. That's true. y equals 1. What about its end behavior? The limit as x approaches negative infinity of f of x is what?
Negative infinity?
What does this graph look like?
What did you say, negative?
As, oh, that's, yes, and that's what I meant to write. I thought you were talking about this. It is not. It is not approaching negative infinity. It is approaching 1. Right? Because that's what it's getting close. So we'll do a proper graph in a second, but it looks like this, yeah?
That makes sense.
Good.
I'm just dumb.
No, just a noob. And as we approach positive infinity, what's the limit as it approaches positive infinity? This time it is positive infinity, right?
What about the end behavior on number?
This is the end behavior. You tell me what it should it actually be?
Oh, we're approaching positive infinity. It's infinity.
Negative infinity, right? It's going down.
After that, and you just didn't say those wrong.
I don't. You got 10 points off, so I may have. I don't know.
So as x is approaching.
As x is approaching positive infinity, the graph is approaching negative infinity.
Nice.
Yes. Okay. And then the graph. So this was not required, but it would behoove you to make a little table with some things on there. The ones I did was -4, which is 1.0024, and -1, 1.05, and 0, 1.3. 3.7 and 3. I don't know. I wrote 3.7 for some reason. I think it's because of the way my thing did it, but whatever. And then 1 and 1. Oh, that's why. 3.7, and then I did 2 and 2 and 4 and 8.4. Then I did all the dots and did all the things and graphed it, and it looks something like this. What other questions from the test? Eight is great.
What did you want us to do here?
Math.
Like sketch the graph of each function?
I wanted
That's
you
what I did.
You didn't graph it correctly. You can't just, when there's an asymptote, sometimes your graphing calculator is going to look like the graph stops there. It does not stop there, and which you would know if you remembered what the parent function looks like. It doesn't stop. It doesn't just go wherever it went.
Yeah,
It doesn't just go. It goes. All right, so 8. We're supposed to expand the log base 3 of 27 b to the 4th. So I think most of us got at least part of this one right. There was one bit that we didn't quite see on some of them, I think. We'll see how we do. Yeah, so what should we do?
You need to multiply the log 3 by each of the parts.
It's not multiplied.
Like separate it out.
Yeah, okay, I thought that's what you meant, but I wanted to make sure. So base 3 of 27 plus the log base 3 of a plus the log base 3 of b to the 4th. Bring the 4 out to the front. That's easy. These last two are the easy ones. It's the first one that we didn't see all the way.
Is it because they 327 is divided by 3?
No, not divided by, but you're on the right track.
Goes into it.
Because 27 is 3 to the 3.
Yes, it is. It's because the log, this could turn into the log base 3 of 3 cubed. Now what can we do?
And then you take that 3 out to the front.
And then the log base 3 of 3 is 1, so it's just a 3. All true.
Nice.
What other questions?
Number 9. What does condensing mean?
Means number 9 was, it's, and I felt fine about it because this is pre-cal, not algebra 2, but number 9 was harder than I really, strictly speaking, would have intentionally done on the test, but it means turning it into 1 log, but we can certainly do it.
Yeah, I have issues.
Number 9 was actually pretty tricky. There was a lot in it. I like it, it's a good problem, but it's tricky. Because it's got several puzzle pieces. It's a good pre-cal question. Terrible algebra 2 question.
I didn't get anything right on this one.
Okay.
I got 20 points off.
Same.
I got 3 points off.
Good for you.
I did something right. I don't know what, but something.
There was some part of it that was accurate. X to the 4th. Oh wait, no, that's a step. I'm reading the wrong line. Let me put my fingers here so I write down the right thing. Plus 4 times the natural log of x.
Plus 2 times the natural log of x minus 1 minus the natural log of x.
All right, so there's lots of things that we could do. What's something we could do first?
Turn that 4 ln x into ln x to the 4th.
Yeah, so putting that in there is a great starting. Garrett, you said weight. Was there a question after the weight, or?
No, I said I have an idea.
Oh, okay. Oh, I thought you said weight. Okay. All right. So there's something else I can go ahead and take care of on the same line because it's not affected.
Can you put that 2 into both the ln x minus 1?
So we can do it that way, which is what you did. You can get the answer. I think it's less confusing to do that a little bit different. To do this first. So what? And just for clarity, for all the things, you could go ahead and just distribute this 2. You could do that next, which does work, and that was totally fine. That's totally acceptable. I think it's less confusing if we push these together first. So what property is this? Yeah, division property. Okay, so we can turn this into 2 times, I'll keep it a square bracket just because, the natural log of x minus 1 over x. And then this one, can't really do anything with it right now, but natural log of x minus 2 and then plus. Great.
Those two, since they're added, we can multiply them, right?
We can. We've got the product property right here. So we can turn this into the natural log of x to the 4th times x minus 2. What can we do with this other guy? We can do something else here. It might be no. But it might be easier to see if I do this. What can we do now?
Can you change 4?
We can do the same thing we did on this one.
You can put that 2 on the...
Yeah, squaring that whole thing. So the natural log of, we'll kind of write this nested weird, x minus 1, x squared. Okay. Now there's a couple things we could do on this line. We could. We certainly could. Go ahead and distribute this x to the fourth. What else could we do?
That was the first half that I actually thought something and it was kind of correct.
Okay, was it this or something else?
That, yeah.
Okay.
It should be.
Good.
Like, that's a possibility, and it actually was.
Yeah, it is.
You square the x minus 1.
Yes. So this is, how do we square fractions? How do we take a power, do a fraction to a power? What do we have to do? Like,
Or do you multiply by the separate?
no, that would be like canceling it. So let me do a real simple one. What is that? 9/16. So how? Yeah, that's what we're looking for. So we square the top and the bottom. Now we've got a binomial squared. We can do our nice little shortcut, right? A squared minus 2ab plus b squared on the top one, right? So this is natural log of x to the fifth minus 2x to the fourth, plus the natural log, what is that, of x squared minus 2x plus 1 over x squared.
And then do you cancel out the x squared? Or is that not a thing?
So we can't yet. We actually are going to be able to get rid of the x squared in a minute, actually. And actually, there's really technically one part of my key that really we need to technically add, and this is pre-cal, so we will technically add it now. But what am I doing? What am I saying? No, we cannot cancel these. That would only be if it was multiplication here. So we can't just cancel those. Yeah, so we've got product property. So this will turn into the natural log of x to the fifth minus 2x to the fourth times, you don't have to put the dot, but just for clarity, I'm putting it in there. X squared minus 2x plus 1 over x squared. And then you have to do the multiplication. That's true. We could pre-reduce, which is not what I did when I was making the key, but we could pre-reduce, couldn't we? Y'all see a pre-reduction that we can do? Actually, let's not confuse things. Let's not pre-reduce.
Yeah.
Because it'll look disappearing-y later. So we got to go and isn't that thrilling?
Do you multiply the bases by each other?
Yeah, 1 times x squared. Yes, ma'am. Mm-hmm. So it would turn into the natural log of x to the seventh minus 2x to the sixth plus x to the fifth minus 2x to the sixth plus 4x to the fifth minus 2x to the fourth. 1, 2, 3, 1, 2, 3. All over x squared. Then we combine like terms. So this would turn into the natural log of x to the seventh and minus 4x to the sixth plus 5x to the fifth minus 2x to the fourth all over x squared.
And then can you take x squared out of everything?
You can. So there are, well, this, you could stop here, turn this into x to the fifth minus 4x to the fourth plus 5x cubed minus 2x squared. This would be an acceptable answer if we need to add a domain restriction first. Because of this, what can x not be? 0. Okay. You could also, and this is a perfectly acceptable answer, you could also inside here factor out an x squared and have it as x squared times x cubed, et cetera, et cetera, et cetera. But either one is fine. Either one would be fine on this particular. This is probably as good an answer as that one.
And so you don't have to show that you took out an x squared, like you don't have to bring it.
Not in pre-calc, because you factored out an x squared and then canceled it, is what we really did, right? Because you factor out an x squared here, it'd be this time x squared times all this, and then that gets canceled. So yeah.
I'm gonna take a picture of that.
Okay. Any other questions on this? 10. That's crazy. Oh, 10 is fun. And it even has a pretty answer.
What did I do wrong?
Apparently it wasn't as pretty as I thought it was.
Or it was more pretty than you thought it was?
I mean, I literally got 1, so.
Oh, I see. Oh, gotcha. Okay.
That's awesome what I got.
Uh-oh. What if my key is wrong? That would be funny.
You marked out my x plus 5. I don't know what this means.
Okay. Let's do number 10. And then we'll get back to trig. The log base 7 of 6x equals the log base 7 of 9 plus the log base 7 of x minus 4.
Can you not just eat away all the log to the set?
Nope, we sure can't. Because it would have to be just log equals log, but we got to deal with this first.
We can combine.
We can, yes. So this would turn into the log base 7 of 6x equals the log base 7 of 9 times that, so distributive property, right? So 9x minus 36. Now we can yeet out the logs, because we got log base 7 equals log base 7 something else, right? So now it's 6x equals 9x minus 36, and y'all know how to solve that.
And the answer is after that, not 1. Oh.
The answer after that, it does not turn into 1, no. It does not, in fact, turn into 1. I don't know, you do the math and find out.
Yeah,
Okay, let's do some trig. Let's do some trig.
well,
Dot and cross products of vectors. That sounds amazing, but that's not what we're doing today.
was it just me, or did I not understand anything from the homework? I didn't feel like we learned any of it. Like the first section.
It was just you. I don't know. We'll find out. I have no idea. I'm just being silly. I can't really answer that question for you, Garrett. We'll take a look. Oh, from 2 through 8?
No,
No,
the
no,
Oh.
chapter
just
40.
yeah.
Oh,
I also didn't know.
I
You
knew
didn't
10,
know
12, 14, and 16, because that was just converting from radians to degrees. And everything else, I looked at my notes and I couldn't find anything to do with it.
oh. Okay. Oh, we didn't really talk about coterminal. It's easy. We actually kind of did, but we didn't. Yeah. But
Is this a lesson or is this homework?
this is. I'm going to give you the answers because we may as well, and then we'll take all the questions that are necessary, which could be quite a few, which is fine. Okay. So let's see. I gave you 2 through 40 or 38.
10 through 40.
Oh yeah. I'm going to read you the answers to 2 through 8 because we're going to do them today. But I mean, either write them down or don't. Who cares? Actually, I'm not going to waste my time reading, but we are going to do 2 through 8. We won't do them all necessarily today, but I'll show you how to do them. So, yeah, anyway. We'll start by reading 10. 10 is pi over 6. 12 is negative 11 pi over 12. 14 is 120 degrees. 16 is negative 45 degrees.
Wow, degrees,
Gasp.
No, in my household, you put on the units, or my parents will be like, units.
They'll beat you up.
Yeah, basically. Beat you up with math.
Beat you up with math. Number 18 is 120 degrees plus 360 in degrees. 480 degrees and negative 240 degrees would be options. And I'm gonna not like read anything else to you for that because you probably didn't do them.
No, I did.
Oh, you did. You went and looked at the book and did the best you got. Okay, great. Number 20 is 225 degrees plus 360 times in degrees. And possible answers are 585 degrees and negative 135 degrees. Number 22 is pi over 3 plus 2 in pi. And possible answers are 7 pi over 3 and negative 5 pi over 3. 24 is negative pi over 12 plus 2 in pi, and some possibilities for the rest of it is 23 pi over 12 and negative 25 pi over 12. 26 is invisible. Where's 26? Oh, there it is. So you could have put, there are different possibilities, but something like 396 degrees is accurate. Number 28 is 6.3 inches. 30 is 33.4 centimeters, and 32 is 206.8 millimeters.
Yeah, that's where I stopped.
And that's where you stopped. You didn't do the formula ones?
It was midnight and I was
Oh, yeah, I remember. I remember the story. Yes. I remember now. 34 is 20 revolutions per minute. 36 is 52 revolutions per minute. 38 is 2.1 feet. And 40A is 3 inches. The saw has 17,592.9 radians per second, which is 26,389.4 inches per second. 5-inch saw is, am I reading this to nobody? Did anybody, I think I'm reading this particular problem to nobody. Okay, great. We'll potentially look at it later. Okay, great. So I'm going to start with doing like number 2 and number 6 so that you can do it with me and you can know how to do it. Okay, so number 2, we are supposed to convert 58.244 degrees to degrees, minutes, seconds notation, which is primarily a nautical thing and is where it comes from. What we need to get is the 0.244 into minutes and seconds instead of points. Okay? This makes sense so far?
vaguely.
Sort of, kind of, right? So, first part of our answer is 58 degrees. Yay, great, that was easy.
And we don't have to put 244.
We don't have to put 244 yet because we're gonna convert it. Make it differenter. Okay? So we gotta convert it to minutes. Okay, now minutes and seconds are pretty easy to remember how to convert because it kind of works the same way as time.
How to convert degrees to seconds?
Fractional degrees, not degrees, but the fractional degrees. We're going to take 0.244 and we're going to multiply that times 60 minutes. And what do you get when you do that? What did you say?
0.64. minutes.
14. So now our answer is 58 degrees. 14 point, what'd you say?
6.4.
6.4 minutes. Now what do you think we're gonna do?
Turn the 0.64 into seconds.
Turn that 0.64 into seconds. That's exactly right. So 58 degrees, 14 minutes, and 0.64 times 60 is
38.4.
38 4
So
seconds.
then you'll round down. It said nearest thousand, and that's the thousandths at this point, or the seconds. Okay.
And then we will round down. So our final answer is 58 degrees, 14 minutes, 38 seconds.
Okay, that makes sense.
Easy money. So to do number 6, we're supposed to convert, excuse me, 126 degrees, 6 minutes, 34 seconds to fractional degrees. So what do you think we're going to do there?
You multiply by the inverse?
Yeah, by the reciprocal, but yes. Six degrees and 6 minutes. 34 times 1/60th. Actually, that's not right. I made a mistake already. In fact, let's write this all down. We could have done this way, actually over here as well. Let's do it all together. I'm gonna write it down and then y'all tell me what's happening because y'all are brilliant. So that's what we're going to do.
Times 60 is 360.
Yes, it is. You didn't say what you meant, but you meant what you said.
1,060.
You didn't say what you meant, but you meant what you said. Okay. So, and then, you're gonna like, right? So, 60 times 60 is what?
I understand.
How did I understand what you say?
I understand.
Seconds are 1/3600th of a degree. Just like seconds are 1/3600th of an hour.
Okay.
Yes. Okay, so what do we get for our answer?
Getting there. You have 126 degrees, 0.1. 0.1.
That might be right. That's not what the key put, but that might be correct. Let me punch it in and see whether and somebody else could punch it in and see whether they agree with. Okay.
What I was saying was correct. I did the rounding incorrectly.
Great. Okay, that's easy money. Y'all can do that in the future. Now, we should do something before we do this. Were there any questions on 10 through 16?
No.
We get those pretty much accurate, or if we made a mistake, we know what we did. Okay. All right. So let's jump to 18, 20, 22, 24. You know all the things that you need to do these problems. We just need to put some meat on it.
I spent a lot of time trying to use my brain.
Well, good. I'm glad you did. It's good for you.
It didn't end up working.
Well, it probably did some good things, just not what you were hoping it would do. So we're supposed to identify all angles that are coterminal with the given angle. Then find and draw one positive and one negative angle coterminal to the given angle. Okay, so we need a definition. What does coterminal mean? Right? What does that mean?
It means if you go loop around in a circle, it comes back to that same point.
Yeah. So it's the same angle in the same position. So terminal is like the ending, right? So the angle ends at the same place. So start by giving a little bit of a sketch of 120 degrees. Where's 120 degrees? Yeah, over there. Over there-ish, yeah? Great. Something like that-ish. I don't know. Doesn't matter. It kind of does, but it kind of doesn't. So that's 120 degrees, right?
Other question, where's the restroom?
There and down the hall, and you keep on going until it says ladies on your left. There it is. Great, gorgeous. So the identify all of them. So we could have another one, excuse me, where we went all the way around and then it hit it again, right? We could keep on doing that forever and ever, right? If we keep on doing that forever and ever, what are we adding each time we do it? 360. So to list all the coterminal ones, you have to do it with an expression. So all the coterminal would be 120 degrees plus 360 times n degrees. Well, times n, actually, the degrees is on everything. It's actually this.
What's n?
N is a number. However many times we roll around. N is a variable. And it has to be a variable because it asks us to list them all. And so the only way to list them all is with an expression, right? Because we don't have infinite ability. Lucy's friends, is that what that said?
Exactly what that said.
That's funny. Okay. All right, so that's part of the answer right there. Done. Easy peasy lemon squeezy. Yeah?
So
That's the list all, that's the identify all of them. Then it says to draw one and one positive, one negative. So I just drew a positive one. We just need to write what it is. So what would this blue angle be?
it would be 180, 480.
Yeah, 480. So 480 degrees. And then how would I draw the negative one?
Oh my gosh.
Going backward.
So I would go from here to here. And it would be negative what?
Negative. Is it negative 1 here? Negative. Is it whatever 160?
Just
160
negative
minus 120?
480.
Is that what it is?
Negative 120 would be over here. It'd be negative 140. Why would it be negative 140?
Something?
Oh my gosh.
Is it 120 minus 360?
You said it backwards, but I think you meant it correctly. Actually, no, it wouldn't be because it's negative. Yeah. Yeah. Because to go all the way around, it would be 360. So it's going to be 360 minus this chunk. Yeah. Easy money. So those are also, Ryan, part of the answer. Let's do a radians one.
Wait, so. Sorry, I was. My brain went away for a second. To get to negative 140, you're doing.
360 minus the angle. Because 360 is all the way around. So, and this is very important. I cannot stress this enough. I've been saying this a lot in this particular class. Make sure you understand why you're doing the thing. Like don't waste your brain power understanding what to do because you'll never be able to answer the question right ever again. If you focus on what to do, focus on why to do. Because the reason why it's 360 minus this is because it's 360s all the way, so it's everything but this, right? Right, so
Makes sense.
good. Good, good, good. Let's do a radians one. Let's do the 24, I think. 24, we're supposed to do the same instructions with negative pi over 12. So let's start with a sketch of where the thing is. I don't know why I drew it way over here, but you know, whatever, it's fine. Where is it? Which quadrant is it in? Quadrants are, it is going to be in quadrant 4. Quadrants are 1, 2, 3, 4. Positive, positive, 1, and then, what is that?
Quadrant 4, right? Reverse. Like, quadrant 4 inverse.
It is quadrant 4, yes. Yeah, you were right.
Going that way instead of that way.
Yes, because negative, yes. Yeah, so going negative, this would be pi, and this would be pi over 2, right? But this is less than that, so it's over here somewhere, right? It's about like this-ish. Something about like those. Oh, radians are so much easier to think about. So much easier. So much easier.
I'm
You're what?
gonna have to figure out radians later.
Well, how about we start figuring them out today? Okay, so this is negative pi over 12. So we need to start out with writing all of them. So we need the expression, right?
So it's gonna be negative pi over 12 plus 360 n.
No. 360 is in degrees.
It'll be negative,
I need it in radians.
negative
Yes, you do. What's all the way around in radians? Well, great.
2 pi.
2 pi. So plus 2 pi n. Wham. Great.
And that's the expression.
That's the expression. That's the all of them part. Right? So now we need 2 more, a positive one and a negative one. Right? There's all kinds of options. Right? Let's do the positive one first. So this one, we draw that. Great.
Draw it. Okay.
So how do I figure out what that is? What math would I, not what it is, but how do I figure it out?
You add in the 2 pi n. No.
Not to do that one, to do the other one.
So subtract that from 2 pi n.
Yes. I subtract that from 2 pi.
Wait. Negative.
I subtract
Minus 2 pi.
the other way around because we want the positive one, right?
2 pi.
Yeah. So we're going to do 2 pi minus pi over 12. So that would be 24 pi over 12 minus pi over 12. So what would that be?
Negative, no, not negative, 23.
We'll get there in a minute.
23 pi? Oh, yeah.
Yes.
That makes sense.
Good. Over 12. Okay, that's a positive one. We could add 2 pi to that, and that would be another one, right? We could add 4 pi to it. That would be another one. Let's do the negative one. So we've got to go, we've already got the, so we've got to go.
So that'd be negative pi over 12 minus 2 pi?
Yes, yes, it would be, yes. Mathematically, 100% accurate. I thought you were going to say something wrong, but you said it brilliantly. Good job. It wasn't because I had lack of faith in you. I just thought that was sentence was going in a different direction.
And we actually have to solve this right, and that's the answer. We're not just giving the expression.
Yeah, Expression has letters in it. This don't have no letters in it. I mean, it's got a Greek one, but that Greek one is actually a number, so it doesn't count. So that would be negative 25 pi over 12. Easy money?
Not easy, but.
Where is it not? No, so that you're getting two things confused. Because you just said understood. That means easy money. So yes. If you understand it, you can do it.
I think that what that means is I understand now, but tomorrow I won't.
Well, don't stop with the negative talk. Do the homework sooner rather than later. That'll help. Not completely, but it'll help. Okay. That was fun. Great. Let's do some equation-y things. Do we need something from 28 to 32, or are we going to jump down to 34 through 40?
What's the length of the intercept arc? What does that mean?
That means use the formula that I gave you at the end of class last time and plug the numbers in and push enter.
Where is this from?
It should be at the end of the notes from Tuesday, theoretically, unless you didn't write it down, which, who knows.
I did.
You did. I can see it all right there. It's beautiful. We may as well do like one of each because we may as well. We'll have the time.
So you want to do 28?
I say we'll have the time because we're squashed for time. It's great. No problem. We'll have the time for the opposite reason of what I was thinking in my head. How did it get to be almost 12:30 already? Just happened.
34, and if we have time, we can go back to 28.
I like that idea, Garrett. It's a good idea. Except I want to do both a 34 and a 38 or 30 or.
Let's do 38 and 34 there.
Let's do 34 because it comes before 38. Why not? 34, we are given angular momentum equals
Do you know what the W is?
S 2/3 pi radians per second. And we want to convert that. What does it say? Find the rotation revolutions per minute given the angular speed and the radius given the linear speed. Great. And the rate of rotation. So,
There were too many words.
we need to find the rotation. We're given the angular speed.
So we know how fast it goes between 2 points.
Between 2 degrees. Yes.
Or 2 radians.
Yes. Yeah. Yes. Yes. I meant that.
Okay, so then.
What's the formula?
Is it the fancy V equals S over T?
So what is that one?
Velocity equals.
Linear velocity, right?
Oh, is that
Vector over
thing over
time.
there means?
Yeah. So that's not it.
And then you have linear moment or angular momentum.
Angular.
equals-
I said the wrong word earlier. Angular speed.
Oh.
It's correct. Sorry. It's right in your notes, I think, but I said it wrong a second ago.
Angle over time.
Over time.
Where is this?
In your notes.
The concept linear and angular speed in the book.
Yeah, it's also that, but it's in your notes. Unless you didn't write it down at the end of the class, and then, it's not there.
I don't think you gave us those ones at the end of class. I think you gave us the V equals S over T, but I'm not sure about the W equals 0.
I think I did, but I may not have. We could go back and look at the tape and see. But there it is.
So how do I label it? I'll just write it down.
This is angular speed. This is angle, this is time.
Angular speed.
And we're trying to figure out revolutions per minute given the angular speed.
We are.
So we have 2 pi over 3. Nice. And that's
Angle over time.
and then we need it's like a 1 second. And then we need to find out
1 second.
over 60.
suspect so.
So it's 125.66 radians per minute.
Did you just look at it in the calculator?
Yeah.
This is, yeah, that's how many,
Or is that revolutions?
that's radians. We want it in revolutions.
So then.
So
No.
let's, okay, hold on.
2
Great.
pi over 3 times 60.
How many, okay, so we need one more formula bit. Sorry. My brain is having to catch up what's happening because they don't have this in a box. And so I had to think about what we were doing. Okay, we need all our conversions up here, yeah? Let's get all our conversions listed. So 360 degrees is how many radians?
2 pi.
2 pi radians.
Is it going to be 20 revolutions?
It is going to be 20 revolutions.
Math right.
Good, good. How many revolutions is that?
1.
1, yeah, right? One revolution will be all the way around, right? 1 revolution.
Rev.
So this number is in radians per second. So it's just a unit conversion, yeah? It's really all we're doing here. We want the seconds to go away and turn it into minutes. And we want the radians to go away. What am I writing? Radians go away and turn that into revolutions, right? You got her done? Way to go.
So 60 seconds over 1 minute.
Yes.
There's 1 minute left in class. Should I just go home?
You should come back and then 1
Whatever.
revolution over 2 pi.
Yes. 60 seconds, minute, 2 pi, 1.
So then it'll be 120 pi over 3. You can get rid of the 2 pi's and then 60 divided by 3. 20.
Per, ooh,
That's per 1 minute.
great.
Hey, give me a second for my smaller brain to catch up.
And how do we do the second part of this?
This is it on this problem.
Okay.
The other one, on like say 38, for example, you are going to use a formula. You were given the velocity. Where are we supposed to find? We're supposed to find the radius on that problem. So how long the thing is. So you're gonna use formula. You're gonna use the formulas that got radius in them. Yeah.
Okay, so you took out 2 pi, and then you did.
And now it's time to leave. I will find you a video for unit circle trigonometry and possibly graphing sine and cosine functions, probably. And we will have those on Tuesday. This is trig now.
Very trig.
Very confusing.
Have you not watched any of the videos yet?
What videos?
The class videos, the last 2
I
of
haven't
them.
even seen class videos.
There's only a couple up there. You have to go and
They're-
search on YouTube.
They're on there.
On YouTube. I think.
They're on there.
Yeah, they're all on YouTube. There's only a
Did you
couple.
post a video for us to do on Wednesday? I didn't see it.
Not a notes video. We did notes in class, which is why it would behoove you to watch the class videos.
Well, I did the class video. I was there for class.
On which day? Oh, yeah, this last one you were. Yeah, that's right. Yeah, yes. Yeah, so you have all the notes that everybody else has probably, unless you didn't go back and get the one that you did miss, which you did do that. Yeah, I think we already talked about that on Tuesday. Yeah, so you will have assignment for the next 2 lessons, unit circle trig and which is kind of a continuation of 4.2, a little bit. And we've kind of talked about part of it already, and then graphing sine and cosine functions will both be due on Tuesday.